Hello students, welcome to the video. This video is about circle chapter, and in this video we are going to understand about some basic concepts of circle. So let's begin with the video. So first of all, what is circle? What is circle? So circle is basically your two-dimensional geometrical figure, okay, such that all points on the surface of a circle are equidistant from the point called the center, such that there is a center and points which are equidistant from this point, from the center, forms the circle. So the distance from the center to any point on the surface of a circle is called radius. I hope this is clear to everyone. Now let's move to the next part, that is circle and line in a plane. In a plane. Okay. Now see, for example, we are having three types of circle and line diagram. First line is not intersecting the circle. Okay, it is not intersecting. And one line is intersecting a circle at one common point, at a single common point. Okay, and then another line which is passing through the circle and it is intersecting at 2 points. So this is your non-intersecting line, and this line is touching the circle at single point and this line is touching the circle at 2 points. So now the line which is touching a circle at one point, at a single common point, is your tangent. So that line is your tangent. And the line which is touching a circle at 2 points, so that line is your chord of a circle. That line is your chord of a circle. So now in this video we are going to discuss about tangent and circle. So tangent, a tangent to a circle is a line that touches the circle at exactly one point. For every point on the circle there is a unique tangent passing through it. Okay, now secant or a chord. So a secant to a circle is a line that has 2 points in a common with the circle. It cuts the circle at 2 points, forming a chord of a circle. So this is your secant, and AB is a chord of a circle. Now, how tangents, we can say that tangent is a special case of secant. So the tangent to a circle can be seen as a special case of the secant when the two and points of its corresponding chord coincide. When these two common points coincide. So when they coincide at one point, so that is your tangent. Okay. Now next part. Two parallel tangents at most for a given secant. So if you are having a circle, right? So there can be many lines which are parallel to each other. So these all are secant, correct? These all are secant. So for every given secant of a circle, there are exactly two tangents. There are exactly two tangents which are parallel to it. So see, AB and CD are the exactly two tangents, right, which are parallel to it and touches the circle at two diametrically opposite points. I hope this is clear to you. Now in this chapter we are having some theorem. So first theorem is tangent perpendicular, tangent perpendicular to the radius at the point of contact. So this theorem states that the tangent to the circle at any point, at any point is perpendicular to the radius of the circle that passes through the point of contact. So for example, you are having a circle, right? And there is a tangent. So when we draw a line from center to the point uh, where tangent is touching the circle to that point, so radius is perpendicular to that tangent. So here we can say that, let's say this is O, this is P, this is X, and this is Y. So OP is perpendicular to XY. I hope this theorem is clear to you. So tangents are always perpendicular to the radius of a circle. Now, second part, the number of tangents drawn from a given point. So if you are having a circle, right, and there is a point in an interior region of a circle, let's say here is a point, so any line through that point will be a secant. Any line from that point will be a secant, correct? So no tangents can be drawn to a circle which passes through a point that lies inside it, right? Now when a point of a tangency lies on the circle, when the point is lying on the circle, so there is exactly one tangent to a circle that pass through it. Okay, and when a point is lying outside the circle, so two tangents can be drawn from that point. Two tangents can be drawn from that point. I hope this is clear to you. Now let's move to the next theorem. So theorem, the length of tangents drawn from an external point to a circle are equal. So when you draw two tangents from the point which is lying outside the circle, so the length from A to B and A to C are equal. So this is your second theorem. So length of tangent drawn from an external point to a circle are equal. I hope these two theorems are clear to you. So this is these two theorems are important in this chapter, and questions are based on these facts only, these notes only. Okay, so I guess I have covered all the basics of a circle. I hope this video is clear to everyone. So in next video we are going to solve some NCERT questions of a circle. Okay, bye bye, take care, thank you.